Welcome to problem of the day 49. This is another calculus problem. Find the derivative, or calculus 1 problem. Find the derivative of this function. So f of x equals ln x to the fourth times sine 4x. So we're going to have to use the product rule, but then there's also a chain rule nested inside. So this is the chain rule, big F prime of x. So that's your derivative equals f prime of x times g of x times f g of x prime. So it just keeps Russian nesting it all out. So we're going to use the product rule first, and the product rule is mini f of x times g prime of x plus mini prime f prime of x times g of x, and I have it broken out here. So mini f of x equals ln for x to the fourth, g of x equals sine x to the 4x, sine 4x. F prime of x mini is where you're going to apply the chain rule. So 1 over x to the fourth times derivative of a polynomial rule. You take the 4 down and minus 1, so you get 4 times x to the third, and then this simplifies to 4 over x. You can see it, shove this over, and then 4 minus 3, so 4 over x. And then g prime of x equals cosine 4x. And then the chain rule happens again, so the derivative of 4x is 4. So then rearrange it for cosine 4x. So now we can plug each of those terms into the product rule, and I have them color-coded. So this equals ln x 4 times 4 cosine 4x plus 4 over x times sine 4x. Now is the simplification process. So we combine these terms, just shove the sign up top there, and then I also multiplied these two together and rearranged that. And then now I took the 4 and the 4, I took the 4 from the exponent here and moved it down because it's a log property, and multiplied those together. So that becomes 16, and that stays the same, so you get 16 ln x cosine 4x plus 4 over 4 sine 4x over x. And then we'll factor out we'll times by x over x. So we get a common denominator, and we end up getting f of x equals 16x times ln x cosine 4x plus 4 sine 4x all over x. And that's our answer, and you can see it all color-coded out and where the terms come from. Please visit universityshortcuts.com for additional problems.